So this video is going to be on going from polar coordinates to rectangular coordinates. And polar coordinates are in the form radius, comma, theta. Rectangular coordinates are what you're used to graphing, and that's just the x and the y that it takes to get to that same point. So first thing you want to do is kind of draw a picture and plot that polar coordinate. So first, we look at the angle. Pi over 3 radians is 60 degrees, so it's a first quadrant angle. And the radius is going to really kind of go along with, or the radius is basically the hypotenuse for this, right? If we count out 5 circles, the 5 goes up here. So all it's asking us to find, like, here's the point, and it wants to know the x and the y to get to that point. So you're basically looking at a right triangle. And you could think of it a few different ways. They actually want exact values here, and especially when it ends up being like a 30, 45, or 60 degree angle, they'll ask for those exact values a lot. One way to think about it is to think about the unit circle. So at a 60 degree angle on the unit circle, the hypotenuse is 1 on the unit circle. And if the angle's 60 degrees, then the y value is square root 3 over 2, and the x value is 1/2. Well, if we're looking at a radius or a hypotenuse of 5, then we would need to multiply each of these by 5 to get our triangle. So our x value would really be 1/2 times 5, or 2.5. And our y value would be 5 square root 3 over 2. Okay. Really, what we found is the x value, remember on the unit circle, the x value is the cosine of that angle, and the y value is the sine of that angle. So really what you're doing to convert these is to get the x, you were taking the cosine of whatever the angle is, and you were multiplying it by the radius. And to get the y, right, we took the radius and we multiplied it by the sine of theta. So if you had gone in the calculator and typed in 5 times cosine of 60, then it would have given you 2.5. If you had gone to the calculator and done 5 times sine of 60, then it's going to give you whatever decimal 5 root 3 over 2 is. So this is kind of like what will always work. But if you do want exact values, you might need to think about it like the unit circle. Okay. Looking at number 2, this one has negatives. So when I see negatives, I go ahead and still do it the same way. So I find the angle, negative 5 pi over 6 is going to be in quadrant 3. Okay, and it's 30 degrees away, right? That's like negative 150 or positive 210. And even though I know that a radius of negative 2 is going to take me back into the first quadrant, I just go ahead and leave it, and I write the negative 2. And when I multiply by my radius or my hypotenuse, then I'll be multiplying by negative 2. And that will still give me a first quadrant angle in the end. A first quadrant coordinate in the end. So on the unit circle, let's go down here. If we were at 210 degrees, then we would have negative 1/2 as the y and negative root 3 over 2 as the x. And I need to multiply both of those by negative 2 because my hypotenuse is negative 2. So my x value will end up being negative 2 times negative square root 3 over 2, which is just going to be a positive square root 3. And my y value will end up being negative 2 times negative 1/2, which is just a positive 1, which makes sense. That's a positive and a positive, positive x, positive y, that's first quadrant, and that's what we thought should happen. Okay. All right, last one is 3 is the radius, the angle's 270 degrees, and these are actually the easiest because 270 degrees is on the y-axis, and I need to count 3 down. So the coordinates in rectangular are just 0, negative 3. Again, if you had thought of it as radius times cosine theta, radius times sine theta, you still would have gotten the same answer. The sine of 270 is negative 1. negative 1 times 3 is negative 3. So these formulas will work if you'd rather think of them that way.